Okay, this is video number 12 in our subdivision series. At this point we have been fine-tuning on our design surface, and I know that I still have some fine-tuning to do here to meet specifications for this project. I've got slopes that are too steep here on part of my site, and I can pretty easily change that just by changing some of the elevation points along the rear lot lines, or even inserting elevation points in between the existing elevation points. So if I needed an additional point of elevation, say right here, to make this slope a little less steep, I could do that, or I could simply change the elevations of these existing elevation points, so that, in this case, maybe I would lower them so we don't have quite so much change in elevation here across the backyards of these lots. But let's say that I'm happy with the way my design surface looks, and now I'm ready to start calculating some earthwork volumes. There's a pretty handy tool in Civil 3D if you have multiple surfaces in your drawing. We can compare those surfaces and actually calculate a volume. And we don't need any advanced calculus to do that. If we go to the Analyze tab of the ribbon, we get the button for the volumes dashboard. So I want to open the volumes dashboard, and it brings up a panel like this. And the third button in on the top ribbon of this volumes dashboard will allow me to create a new volume surface, and that's what I want to click on. I want a new volume surface. So I click on that, and then it asks me to define a few parameters here. First of all, what sort of surface do I want? In this case, my existing surfaces are tin surfaces, triangulated irregular network surfaces. So I'm going to continue using that tin surface. I will leave the layer alone, but I can name this something. And in my drawing here, I think I have 4 surfaces, so this would be surface number 5. I want to keep them separate, so I will call this base to design comparison. And you can name it whatever you want, but name it something that will make sense to you. I can pick which style do I want to see this surface displayed as. I'm going to change this. I don't need to see 10th foot contour intervals, and I definitely don't need to see triangles. So I'll put this on a 1 in 5 background layer, just as an example here. And I could change the render material as well, but notice these are not maybe what you expect them to be. So I'm going to leave that by block, or by layer would also be fine, or you can just leave it the way it was and not change anything. But what we do have to specify here is which 2 surfaces are we going to compare. So base surface, this is going to be my existing topo, and I have to pick that from the list of surfaces in my drawing. So that would be this min topo. I had to reload my existing surface, so I've named it min topo reload. So that is the existing surface that I'm going to use as a base for this comparison. And then what surface do I want to compare to my base surface? So I again have to pick this from the list of surfaces in my drawing, and I want to compare that design surface. So between the existing surface and the surface we are designing, I would like to know how much earth do we need to move on this site. So after I specify all these parameters, I can click OK. And don't be surprised if you get some errors. Like, for example, it's telling me that one of my surfaces is out of date, so I need to go to my tool space and look at these surfaces and rebuild. So I'm going to rebuild my design surface, and then I will rebuild my comparison surface. Again, don't be surprised if you get some errors. Green check will get rid of the errors, and we should be able to see now this volume comparison. So base to design comparison. This is my surface, and here's the style, here's the area, 2D square footage, and here it's telling me cut and fill with a net adjusted. So in this case, I've got about 4,000 yards of fill, pretty well balanced considering how much earthwork is going on and the size of my site. Of course, you You may want to try to balance this even more, get this closer to 0 so you're not having to, in this case, buy some extra fill. But whatever the parameters or specifications for your project, you can start to work towards a 0 net if that's what you're trying to do. And I can see here, this is our volume comparison surface. Let me turn off my design surface display just so we can take a look at the comparison surface. So I'm putting my design surface on a no display. So this is the comparison surface that we're looking at now. Here's all the cut and fill that needs to happen to make our design surface happen on site. And based on this, I'm seeing areas of lots of cut and fill, areas where we're going to be changing pretty significantly some of the existing topography. But again, this is a pretty handy way to at least get a rough estimate for earthwork and volumes. So again, you can find the volumes dashboard on the Analyze tab of the ribbon, and you can have multiple comparisons in here. Let's say I wanted to compare my existing to just my corridor surface, or maybe my corridor surface to the design surface. Depending on what numbers you're trying to generate, we can have multiple comparisons going on. But again, I think that is a pretty handy tool to get some very basic earthwork calculations without having to know anything about calculus at all. And so this sort of is a conclusion for part 1 of our subdivision design series. Again, I know I've got some fine-tuning to do on my design surface. I need to do some more feature line work. But at this point, I've got a pretty good idea of how my layout is going to happen in 2D and 3D. I have some numbers that I can start working with in my volumes comparison. And really from here on out, there's a lot of fine-tuning that we're going to do, especially with our design surface, to make sure that we're getting water to flow where we want it to, and then maybe we have to put in some sort of treatment or retention areas, and definitely we would want to then add pipe network under our corridor. Likely as a residential subdivision, we would need some storm drains and sanitary sewer and potable water, so plenty of other civil 3D work we can do on this project. But for now, our 2D layout and 3D earthwork calculations are pretty well taken care of. So we will start with some of the intersection design and utility design in subsequent videos.